On this example, we have 3 logarithmic functions given and 3 logarithmic function graphs. We want to play a matching game here and try to get them matched up correctly. So to do so, what I want to do is first start out with, if we were thinking just y equals log base 4 of x. The most basic of these, we'll identify some key points and then we'll move them around using transformations of the graph. All right, so the key points that we want to identify are going to be all logs of this very basic form start out with 1, 0 as being one of the key points. And I'm using log base 4 because you'll notice over on the right-hand side, all of these happen to be log base 4s. The second key point is going to be whatever the base is of the log, comma, 1. All right, so keeping those two in mind, let's think about what transformations have been going on with the graphs on the right-hand side. All right, so the very most basic one we have is the bottom one. We just have this plus x, or x plus 2 going on here. So let's deal with that first. All right, because this 2 is attached directly to x, it's going to be a horizontal transformation. In this case, horizontal transformations kind of work counterintuitively to how we think they should. Because we're adding 2, we actually move everything to the left 2 units. So let's think about our key points. We had a key point that was at 1, 0, but we've picked it up and moved it to the left 2 units. So that key point is going to go over here to -1, 0. And then what about that second key point? All right, the key point was at 4, 1. We've picked it up and we've moved it left 2 units as well. So it's going to land here at 2, 1. All right, the only graph that has those two key points going on is graph A. All right, next, let's go ahead and use those 2 key points that we have and think about the next one up here where it's the same function going on, except we have a negative. Now, a negative as a transformation, what that always does is it's going to be a reflection of some sort. So in this case, because this negative is attached to the entire function instead of directly to x, it's going to be a vertical reflection. All right, a vertical reflection, what that's going to do is that's going to affect our y values. So if we start with our key points, -1, 0, and we multiply that y value by a negative, we still end up with the same key point. It's still going to be -1, 0. By process of elimination, we may already be done with this one, but let's go ahead and identify -1, 0 is going to be on this graph. Then the second key point is we take 2, 1, and we multiply that y value by a negative, and our second key point is going to be 2, -1. All right, so +2, -1 is going to correspond with this point right here. And you'll notice that's at C. That's graph C, the green graph over on the left-hand side. All right, one more to go here. Of course, we've already identified 2 of these 3. We can, by process of elimination, kind of guarantee that B is going to be the top one. Let's talk through the thought process. All right, again, I'm going to go back to this bottom and the key points going on here. And let's discuss what's going on with the only addition is this negative. Again, it's going to be a reflection because it's a negative being applied, but in this case, it's a negative attached directly to x. So it's going to be a horizontal reflection. So horizontal reflections affect our x values. So I'm going to go down here to our 2 key points from the bottom one, and that x value is going to get multiplied by -1, therefore giving us +1, 0 as one key point. And then this x value from the 2, 1 gets multiplied by a negative, so we get -2, 1. And let's look at our graph over on the left-hand side. We have 1, 0, going to be this point here, and -2, 1 corresponds with this point here, which goes along with graph B from the left-hand side. So take your time, identify your key points, and then use transformations to get additional key points on the new graph. Hope this helps out. Good luck.